Okay, so last night's homework. This is a typical question from last night's homework. The 3 cubed roots of blah. All right, what's new about today is we're just going to have one extra step. I'm going to pause so I show you a new one for today. This one is one of the ones on tonight's homework. I'm going to assign you this one, which is the 3 cubed roots of negative 8i, which is really 0 minus 8i. You find the cis for it, and can you see, I've got it right now, but can you see common mistakes people would make when writing this? They wouldn't say 8 cis negative pi over 2. They all kinds of options on how ways to screw this up. Yes. Negative 8 cis negative pi over 2, because this has a negative 8 on it. Well, why isn't it a negative 8? If it's r comma theta, have you ever seen a negative r? Think about that. Have you ever done a negative r? Whenever you made those triangles, did you ever make the hypotenuse part be negative? Mm-mm. So it's an easy mistake to make. In fact, I made it in last hour. It's one of the reasons I'm re-recording this. I thought that that was negative 8, didn't even think about it, because it's like, what's going down 8? But r's are always positive. Otherwise, we'd have to worry about it in all the other triangles too. Okay? So it's positive 8, and then the other mistake. Anybody see another mistake that could easily be made? Yes? Yeah, they'd say, if they got the 8 part right, cis 3 pi over 2, and not supposed to say it that way, because anytime you go past what? Pi, then you're breaking the rule. You're supposed to go the other way then and say this as negative pi over 2. All right, so those are common mistakes, but I'll clean it back up again to... All right, so I got asked a good question. They said, okay, so if I do have this right now, how do I actually give the actual answer? Well, first of all, we're going to do a practice one of the 3 cube roots kind of thing. Okay, but when you're done, do you get what's going to involve de Moivre and adding 2 pi k and all that stuff? And when you're done, you'll have something cis something. You'll have 3 of those, right? Because they're supposed to have 3 roots. The only thing that's different is it'll be something cis something, and they want you to graph it in rectangular. So let's make sure you get the difference. Let's say I had something that said 2 cis pi over 4, but they want it in rectangular. Would you please take this and turn it into rectangular? That's the type of process you'll use at the end to take your 3 answers, change them over into rectangular. All right, I'm going to pair you with people now for you to work with today, because there's some tough questions, and it's going to work. It's going to help a lot to have somebody to work with. So, all right. So I'm thinking that you were thinking, here's pi over 4, and I go out 2. And so what's the big deal? I've graphed it. That's not what I asked for. I asked for the rectangular coordinates, which is this and that. Okay, so what are they? If this is a 2, is it the 1, 1, 2 triangle? No. But if you wanted this one, I would make the classic 1, 1 root 2, and then I can say things like x is to 1 like 2 is to root 2. So apparently x is 2 over root 2. Raise your hand if you had that one right. Excellent. And the y, because these are in a 1, 1 root 2 scenario, they must be the same, and so therefore the y is 2 comma root 2. Now if you were asked to write this in complex rectangular form, the answer would be 2 over root 2 plus 2 over root 2. True or false? False. It's close. What else do I need? An I. That now is in complex rectangular. This is in complex polar. Do you see the difference? Yes?
Okay, so I know I got square root of 2 instead of 2 over square root of 2.
Ah. It is the same thing. If you times by root 2, you will get 2 root 2 over root 4. which is 2 root 2 over 2, and the 2's cancel, and it's just root 2. I know that's weird, but this is a root 2, and that is a root 2. So yes, that's totally okay. Yes?
Then wouldn't that make the legs root 2?
Yup. So watch what happens. This squared, which is what? This squared, which is what? Equals that squared, which is 4. So 2 plus 2 makes 4. It worked. So why does that feel wrong to you to have a root 2 and a root 2 there?
Well, I don't get why it's divided because if it. I was thinking wrong. I thought rectangular was just like the actual 4.
It is. It's this far over and that far up. Now I'm just saying, I just proved that this is the same as root 2. I just proved that right here. Okay? So root 2 is the same as 2 over root 2. They're equal. They're equal to each other. All right. So let's do a practice of the 3 third roots of etc. I'll pause while we figure that out. Would you please take this -1 minus I, find cis form for it, and then find the 3 third roots of it. This question is important. I hope you get that we are doing this to the 1/3. There's only one way to do a third root. I know third implies 3, but third root implies 1/3. Okay, so did you get cis form for it? I hope you did. I hope you went this way 1, and that way 1, -1 and -1. And then that meant you're in the 1, 1, root 2 triangle, and therefore you should have said you were at root 2. Notice that the R is positive, always. We didn't even think about making that negative, did we? All right, because R's are defined as positive, so be careful with that. And then it's cis, and then this angle here is a 45, also known as pi over 4. But you got to get to it this way, because it would be past 1 whole if you go that way. So negative 3 pi over 4. Raise your hand if you had the correct cis form for it. All right, good. Now we need a couple little things to be added there to be able to generate 3 third roots. I could do a third root pretty easy, but 3 third roots adds complication. This would be the third root, but I don't want to just get one of them. I'm going to do the demov after I've added what? Plus 2 pi k, and then I'm going to do the third power, and then demov is all about demove of the exponent. So I'm going to put another 1/3 up here, and then I can put that there, and this here, and then maybe one more, make this one red. And that one can go here. I'm going to get rid of that. Final answer, see if you can handle this. 2 to the 1/6. Ooh, what just happened there? Because 2 to the 1/2 to the power of 1/3. Cis. And then if k equals 0, which is the first case, k equals 1 will be the second, k equals 2 will be the third. If k equals 0, this whole part at the end won't matter. So I can just figure out the first part, which is negative 3 pi over 12. If I simplify it down, negative pi over 4. Is that correct? Okay. And if you had said negative 3 pi over 12, yes, I get why you would do that, because maybe you'd want a common denominator of 12. All right, but you need to simplify it when it's done. So I'm done. There's my first answer. Now k equals 1. So I'm going to go through and put in this part with a 1. So it's 2 to the 1/6 cis. I would still use negative pi over 4 plus that component. And that component now has 2 pi over 3 times 1, which is 2 pi over 3. But wait, why can't I put them together? Because they don't have a common denominator. So that's like you were saying, maybe we should have left this as 12ths. And then I'd have negative 6 twelfths and positive 8 twelfths. And when I put the negative 6 and the positive 8 together, I get 2 twelfths pi, or that does reduce. Oh, wait, question? Negative 3 twelfths and positive 8 twelfths. Did I say that wrong? Okay, sorry. That's positive 8. That's negative 3. Total positive 5 twelfths pi. This is like my work, and then my answer for the angle is at the end there. So 2 to the 1/6 cis, 5 pi over 12. And that's supposed to be a 6. All right, and then has anybody caught on to the whole how much did it grow thing, so we can just do that again? It grew by, well, let's change it back to twelfths again. Negative 3 pi over 12 changed into 5 pi over 12, which when it grew by 8 pi over 12. So we can add 8 pi over 12 to the 5 pi over 12, making a total of 8 and 5 makes what? 13 pi over 12. And it's wrong. Why? Because it went past pi, and there'll be yes, there's a 1/12 involved, but it's not. The answer isn't 1/12. Where is 13 pi over 12? Well, here's 12 pi over 12. 13 pi over 12 went just a little too far, so we got to write that in another way. Negative 11 pi over 12. All right, which part didn't you get? Did you get the 13 pi over 12 or not?
I did it a different way where you just like do it again and plug it to, and I got 7 pi.
Oh, right. I will double check it by doing that. I'm going to try to remember what I got. Negative 11 pi over 12. Let's see if I can do it the other way, which is to not figure out how much it grew by, but to just stick in a 2 in here, right? Okay, so then I should have had negative pi over 4 plus this part, which will be 2 pi times 2, which is 4 pi over 3. I bet it was just a common denominator thing, wasn't it?
I like transferred 3 pi over 4 to 6, or I did like negative 3 pi over
As long as you found it, it's cool. So 16 and negative 3 makes 13 pi over 12 again. And once again, we can't leave it that way. Got to say negative 11 pi over 12. Whew! Now that's a lot. That is complicated, and that's about as hardcore as it could possibly get. Except for on tonight's homework. Because on tonight's homework, you would have to graph this. So how are you going to graph this? Easy as pie. Nice. Okay, we're going to pull out something called Wolfram Alpha. It is a very powerful app. So everybody grab your iPad, find a browser that you trust, and go to wolframalpha.com. I'm going to pause while we do that. All right, so we're on Wolfram Alpha, and we type in 2 cis pi over 4, and it knows what we mean. It can speak trig, in fact, complex polar form. All right, so if you look down here, we've even got the polar coordinates of it and a graph of it. But what if we wanted the 4 fourth roots of it? Do you think it'll know that there's 4? It's pretty smart. Probably will. How are you going to put in the 4th root? I'd put parentheses around the whole thing because we don't want it to just put our angle to the 4th. You know what I mean? All right, then to the power of caret, and I'm going to put the 1/4 in parentheses also because I just have trust issues with fractions. Otherwise, you'd be putting it to the power of 1 and then dividing everything by 4, and that's not what we want. Okay, to the power of 1/4. I hit enter. And interesting, they got the 4th root of cosine I sine. That's actually kind of what I'd expect. Then, here's the really interesting part. The answer, they just put one answer up at first, but then if you scroll down, here's all 4 answers, and they even connected them in this funky way. There's your 4, gentlemen, look at this. Scroll down, find them, the 4 4th roots. I'm going to ask you to look at them thoroughly and try to figure out what could you say about the roots. Yes, sir? They are equal distances from what? From each other or from the radius, or from the origin?
And each other.
Ah, that's it. It took you guys much less time than the other class. I'll say it again. I'll repeat what they said. It's equal distance from the origin and they're equal distance from each other. All right. If I say this in a different way, do you get if I connected the dots that I would get a square? And if it's truly a square, do you get that that means all the sides are equal? And if all the sides are equal, do you get that that means that the distance from the dots is the same? Now, is every dot equidistant from every other dot? No. Because, why? Well, if you think about it, it makes triangles. If I want to say this distance is equal to that distance, absolutely true. Okay, but are those distances equal to that distance? That doesn't make sense. That can't work. But, all right, just wanted you to notice the pattern, because when I want you to just predict for a moment, just use a prediction. If I did the 3 third roots of the same thing, I want you to think about what it would look like. Kind of like a peace sign. That's a good way to think of it. All right, I want you to try it. Go up to the top and change it to, only one number needs to change. We're going to make it the 3 third roots. There it is. That changes to a 3. Boom. Need to scroll down a bit. And there, look at that. All right. It's the sort of the, I think it is. Oh my gosh, I wonder if that is the Mercedes sign. Like, I wonder if that's how they got it. They're all engineers. I mean, that company has got thousands of engineers, and it's an engineer type thing. I wouldn't be surprised. Although I wonder if it's turned a little bit. Like, in real life, is a Mercedes symbol turned like that? Or does it have the bottom spoke sticking straight down, I wonder? Oh, it's straight up. Okay. So I bet we could rotate this if we wanted to, but it would add a lot more complication, and we don't have time for that right now. Okay. Look at all these alternate representations. Like, think about it this way. Do you get that up until now, this graph would have been like, whoa, what are they even talking about? When you move up into higher level math, then you could say, well, this is the stuff that we're doing in our calc class now, or whatever. See what I'm saying? Actually, that's beyond calculus A anyway. That might be calc B, or etc. Anyway, so this is alternate representations, different ways you could write it. So it's really not incredibly hard. They've just got an extra H thrown in that you don't know what it means. And I don't either, to be honest. It's been too long since I've had it. This is a series. You guys are going to do some series as you move on. And these are particularly nasty series. But yeah, you're going to learn series next year. Okay. So enough with Wolfram Alpha. I'll pause when we get back to our other stuff. All right, so we're back to what are we supposed to do for tonight? Tonight you're supposed to do the 3 third roots kind of thing, but then when you're done, you graph them. Can you use Wolfram Alpha? No. But we've chosen numbers that work out nice so you can find the rectangular coordinates. It's not like 13 pi over 16 or something where you'd never be able to find it by hand. Okay? So, would you please start with this one, and remember it's positive 8 cis negative pi over 2 is its cis form. And then just find the 3/3 roots. Then the added complication is you got to change them back to rectangular and graph them. Then we are skipping number 74 here. As you can see, it is scribbled out. And then the only other one on the page, I'll pause while I find it, is this one, and that's the other one I'm assigning. So the first problem in the assignment, and then the last one. And it's the 9, but then again, they're just roots of -1. So it's really easy to find it in cis form, and the numbers work out really nice because there's a 0i component. You can think of it as -1 plus 0i. You know where to graph it really easy, and it's not too tough. Now, what do you think the 9 roots look like? I bet you if you connected them, it'd be almost like a circle, kind of in a circle, right? And there'd be 9 dots. It would technically, do you guys know what the name of a shape with 9 sides would be? Nonagon. Very good. You remember your middle school. It's probably when you learned that, or maybe late elementary. Okay, that's all I got for you for today.